Most gold isn't hidden from sight. It's hidden from understanding. Every year, prospectors walk across gold-bearing ground without realizing what lies beneath their feet. The biggest clues are often not glittering nuggets or obvious quartz veins, but subtle geological signals in the landscape. Changes in terrain, sediment patterns, and rock structures can reveal far more than most people expect. Professional prospectors learn to read these quiet signs because they often lead to the most productive ground. Today, we'll explore why some of the richest gold-bearing areas are overlooked, misjudged, and passed by every day. If you've ever searched for gold, you've probably been taught to look for obvious signs: quartz veins, iron staining, exposed bedrock, bright colors in the rock. But here's the problem. Most of the ground that actually holds gold doesn't announce itself. It doesn't stand out. It doesn't look exciting, and that's why it gets ignored. Today, I want to show you why the quiet geological clues matter far more than the obvious ones, and how experienced people miss gold simply because they're trained to look for the wrong kind of signal. This isn't about spotting something flashy. It's about understanding what nature does when it stops drawing attention. By the end of this video, you'll know what to notice when nothing looks special, and why those are often the places that matter most. Most people enter gold country already searching for contrast. They expect something to jump out at them: a sharp color change, a vein cutting through rock, a dramatic exposure that looks different from everything around it. That expectation shapes every decision they make. If nothing stands out, they move on. What they don't realize is that gold is rarely found because something looks different. Gold is found because something behaved differently, often quietly over long periods of time. Nature doesn't always mark those moments clearly. In fact, the most important geological clues are often the ones that blend in. Quiet ground doesn't mean inactive ground. It often means settled ground. And settlement is where gold belongs. One of the biggest mistakes people make is assuming that obvious signs are reliable indicators of value. Quartz is obvious, iron staining is obvious, broken rock is obvious. But obvious does not mean important. Those features are common. They exist in countless places where no gold ever settled. Quiet clues, on the other hand, are rare. Not because they don't exist, but because they're easy to overlook. They don't shout. They require interpretation. And interpretation is where most people stop paying attention. When experienced prospectors miss gold, it's rarely because they failed to notice something dramatic. It's because they dismissed something subtle. They looked at ground that appeared uniform and decided nothing happened there. But geology doesn't work in dramatic moments alone. It works through small changes, repeated over time, a slight reduction in slope, a minor widening of a channel, a gradual change in sediment size. These are not exciting to look at, but they are decisive. Gold responds to those changes far more reliably than it responds to visual drama. Another reason quiet clues matter more is because gold doesn't behave like most materials. It doesn't move easily. It doesn't float. It doesn't spread evenly. Once gold finds a place where energy drops enough for it to settle, it tends to stay there, even when everything else continues moving. That creates locations that look completely ordinary on the surface, but have a very specific internal history. Most people never learn to read that history. They're taught to hunt for features, not processes. They're trained to identify what looks like gold country, not what acted like gold country. That difference is critical. Quiet clues are not things you spot instantly. They are things you notice when you stop rushing to judge. One of the most powerful quiet clues is consistency. Not visual consistency, but behavioral consistency. When material size remains similar over distance, when gravels are evenly packed, when layers repeat without interruption. This kind of ground looks boring. People assume nothing happened there. But consistency often indicates long-term stability. And long-term stability allows heavy material to accumulate. Gold needs time. Quiet conditions give it that time. Another quiet clue is absence. The absence of large cobbles, the absence of angular rock, the absence of chaotic layering. People look at these areas and think material moved through too fast. In reality, absence often means sorting. Nature removed what didn't belong there. Gold, being heavy, was left behind. Quiet ground is often clean ground, and clean ground is often productive ground. But because nothing stands out, people don't stop. They associate effort with excitement. If something doesn't look interesting, it doesn't feel worth the work. Gold doesn't care how something feels. It responds to physics. Another subtle clue people overlook is transition, not contrast. They look for sharp changes instead of gradual ones. But gold doesn't require sudden shifts, a slow narrowing of a creek, a gentle change in gradient, a subtle difference in sediment rounding. These are easy to miss unless you're actively looking for them. And most people aren't. They're scanning, not observing. Quiet clues require observation. Another reason obvious signs fail is because they attract attention. Everyone checks them. Quartz veins get sampled repeatedly. Exposed bedrock gets worked over and over. Quiet areas get ignored. Gold often survives where attention doesn't linger. That's not coincidence. That's human behavior interacting with geology. Gold doesn't hide intentionally. People just don't look where nothing calls for attention. Another quiet clue is compression. Tightly packed gravels, hard layers beneath loose material. Resistance when digging that doesn't match what's on the surface. These are physical clues, not visual ones. You don't see them until you engage with the ground. And many people never do, because visually it didn't invite them to. Quiet clues often require contact, touch, digging, testing. They don't reward quick glances, they reward patience. Another overlooked indicator is repetition without variation. Most people interpret repetition as lack of interest, but in geology, repetition often means a stable process operated for a long time. Long time equals opportunity for gold to accumulate. Chaotic environments move material constantly. Stable environments sort it. Gold prefers the latter. The problem is that stable environments don't look exciting. They look settled, and settled ground gets walked past. Another angle people miss is that obvious signs often reflect source, not deposition. Quartz veins may indicate where gold originated, not where it ended up. Iron staining may show oxidation, not accumulation. Gold is rarely where it was born, it's where it was dropped. Quiet clues point to where movement stopped, not where it began. And that's the distinction that separates casual searching from meaningful evaluation. Experienced prospectors often trust obvious signs because they feel decisive. They give the impression of certainty. Quiet clues feel ambiguous. They require judgment, and judgment feels risky. But gold is rarely found by eliminating risk. It's found by managing it. Another reason quiet clues matter more is because they are contextual, not isolated. A single quartz vein means little on its own, but a consistent gravel size, a stable channel shape, and a compacted layer together tell a story. Quiet clues rarely appear alone. They work in combination. People trained to look for single dramatic indicators miss the story because they're waiting for a headline instead of reading the paragraph. Gold accumulates where multiple quiet factors align, not where one loud feature exists. One of the most damaging habits in prospecting is ranking signs by how impressive they look. Impressive does not mean important. Subtle does not mean insignificant. Quiet clues often determine whether gold could exist at all. Obvious signs merely suggest it might have once. That difference matters. As you gain experience, your brain becomes faster at categorizing terrain. That speed can work against you. You decide too quickly what matters. You overlook what doesn't demand attention. Quiet clues don't compete for attention. They require intention. And intention is something most people stop applying once they believe they already know what to look for. This is where gold stays hidden, not because it's rare, but because it's quiet. In the next part, we're going to go deeper into how professionals train themselves to notice these quiet clues without slowing down or second-guessing everything, and how they correct the instinct to chase obvious signs. Because the land doesn't reward what looks impressive, it rewards what makes sense. The reason quiet geological clues matter more than obvious signs is not because obvious signs are wrong. It's because obvious signs are late. By the time geology becomes loud, the system has already revealed itself to everyone. And gold, by its nature, does not reward crowds. Quiet clues exist earlier in the story. They exist before excitement, before disturbance, before repeated testing strips the ground of its easiest value. This is why experienced prospectors, even very skilled ones, still walk past gold, not because they lack knowledge, but because experience can harden expectations. Experience trains the eye to look for patterns, but it can also train the eye to ignore anything that doesn't match those patterns. When someone has spent years finding gold near bright quartz, iron-stained gravels, or classic textbook locations, their mind starts filtering out anything that doesn't fit that picture. Quiet clues don't announce themselves as gold indicators. They appear as small irregularities, minor inconsistencies, subtle deviations from what looks normal. And the mind, especially an experienced one, is very good at dismissing those as noise. Gold does not care about human pattern recognition. It responds only to energy, gravity, and time. A system can be perfect for gold accumulation and still look uninteresting. This disconnect is where gold hides in plain sight. One of the most common quiet failures happens when prospectors rely too heavily on surface signals. Surface geology tells only the most recent chapter of a much longer story. Gold, however, is loyal to older chapters. It remembers where it fell, where it stopped moving, where energy last failed to carry it any farther. If the surface has been reworked, even slightly, the visible clues may no longer align with where the gold actually rests. This is why quiet clues often appear below expectations, not above them. Consider a stretch of ground that shows no obvious mineralization, no bright veins, no dramatic coloration, no visual excitement. But the slope angle subtly decreases. The gravel suddenly becomes denser. The layering becomes more defined. To most people, this is meaningless. To gold, this is a stopping point. Energy dropped here. And when energy drops, gold obeys immediately. Another reason quiet clues matter is that they are resistant to fashion. Prospecting trends change. Certain rock types become popular. Certain methods get repeated. Certain signs become famous. But gravity does not follow trends. Quiet geological behavior remains reliable regardless of what people are chasing at the moment. This is why professionals who work for long-term yields pay attention to systems, not signals. A critical quiet clue is persistence of form. When a landform has maintained its shape for a very long time, it suggests stability. Stability allows sorting. Sorting allows settling. Settling allows gold to concentrate. A channel that looks unchanged. A bench that has resisted erosion. A low-energy pocket that keeps its structure season after season. These features rarely attract attention, but they quietly outperform dramatic terrain over time. Many experienced prospectors trust their memory too much. I've been here before. I already tested this area. There was nothing here, but quiet clues can change without changing appearance. A slight shift in water behavior, a subtle redeposition event, a small seasonal rework. Gold may arrive quietly after the first visit. The ground looks the same. The value does not. Another overlooked factor is scale. Most people search at the wrong scale. They think in terms of locations. Gold thinks in terms of inches, a few centimeters deeper, a slight move sideways, a narrow transition line. Quiet clues often point not to where to dig, but how precisely to dig. This is why some people find nothing while others recover gold just feet away. Noise distracts. Loud geology creates confidence. Confidence can shorten observation. Quiet geology demands attention. It forces you to slow down, to compare, to question why something is slightly different. This mental state is where gold is most often found. Another reason quiet clues outperform obvious signs is time compression. Obvious signs often indicate repeated movement, flooding, erosion, exposure. Each event redistributes gold. Sometimes it enriches, often it disperses. Quiet environments experience fewer dramatic events. Gold settles once and stays. This is why boring-looking areas can hold gold longer than spectacular ones. It's important to understand that quiet clues are cumulative. One subtle signal means little on its own, but when multiple quiet indicators overlap, stability, mismatch, transition, absence, layering, the probability rises sharply. Professionals don't look for certainty, they look for convergence. Quiet clues converge. This is also why maps and textbooks can only take you so far. They show what is known. Quiet clues often exist where no one bothered to document because nothing looked remarkable. Gold does not require documentation, it requires conditions. When you learn to value quiet clues, your behavior changes. You walk slower, you observe longer, you dig less, but more accurately. This alone increases efficiency. Efficiency increases recovery. Recovery builds confidence rooted in reality, not hope. The greatest advantage of quiet geological understanding is independence. You stop relying on rumors. You stop chasing what others are chasing. You begin trusting physical evidence instead of popular belief. This is where prospecting stops being luck-based. It becomes repeatable. And this is the point most people never reach. Not because it's difficult, but because it requires letting go of obviousness, letting go of excitement, letting go of the need for visual confirmation. Gold does not reward excitement. It rewards understanding. If you take one lesson from this entire video, let it be this: the quiet ground is not empty. It is simply unreadable to those who have not learned its language. Once you learn that language, the landscape changes permanently. You stop asking where gold might be. You start seeing where it must be.
You just watched how ordinary rivers across America are quietly carrying gold right under people's feet. But here's the question nobody asks. If rivers are carrying gold, where is that gold actually coming from? Because gold doesn't just appear in water. It has to come from somewhere. And what if I told you that some of the ugliest, most ignored rocks in the United States are actually the original source of that gold? Not shiny rocks, not obvious ones, not the ones people stop to pick up. I'm talking about rocks most people walk past without a second glance. Rocks that look worthless. Rocks that look broken. Rocks that don't even look like they belong in a gold story. But hidden inside them is where everything begins. And once you understand this, you'll never look at hills, deserts, or even roadside cuts the same way again. Because the truth is, gold doesn't hide in beauty. It hides in disguise. So let me ask you something. If you were standing in the middle of a dry American hillside, surrounded by rough, dull, unattractive rocks, would you know which one is worth thousands of dollars? Or would you walk away like everyone else? Today, we're breaking that illusion because these 5 rock types found across the United States are quietly responsible for some of the richest gold deposits ever discovered, and almost nobody is paying attention. Let's start with something that doesn't look like gold territory at all. Syenite. At first glance, syenite looks like a mistake. It's coarse, it's uneven, it doesn't sparkle the way granite does. In fact, most people confuse it with just another random rock. But here's where it gets interesting. Syenite forms deep underground, in environments where molten material cools slowly. And when that molten material is rich in minerals, it creates pathways, tiny cracks, fractures, open spaces. And those spaces, they become highways for mineral-rich fluids. Now imagine hot, pressurized fluids moving through that rock, carrying dissolved gold. Over time, as those fluids cool, gold begins to separate, not in big obvious chunks, but in tiny, hidden concentrations, locked inside the structure of the rock. This is how gold starts its journey. And when erosion begins, rain, wind, and time start breaking that syenite apart, bit by bit, releasing that hidden gold into the environment. Eventually, that gold ends up where you saw it before, in rivers, in streams, in places people actually look. But the source, it was never the river. It was the hill, it was the rock, and syenite is just the beginning. Because the next rock on this list is even more deceptive. Dolomite. Now this one is dangerous, not physically, but visually. Because dolomite looks clean. Almost too clean. It often appears light-colored, soft, sometimes even chalky. It doesn't scream value. It whispers, ignore me. But dolomite has a secret advantage. It reacts chemically. When mineral-rich fluids pass through dolomite, they don't just flow, they interact. They dissolve parts of the rock and create cavities, spaces, openings, and those openings become perfect traps. Gold doesn't just pass through. It gets stuck, captured, locked in place. And over time, those small trapped particles can build into something significant. But here's the catch. From the outside, dolomite still looks boring. So nobody checks, nobody tests, nobody looks twice. And that's exactly why it works. Now think back to the river. All those tiny gold particles you saw. Many of them started in rocks like this. Not dramatic, not exciting, but incredibly effective. Now let's move to something that looks stronger, harder, more serious. Diorite. This is the kind of rock that feels like it belongs in construction. Dark, dense, heavy. If you saw it on a trail, you'd probably assume it's just another tough, useless stone. But diorite forms in conditions where pressure and heat are intense. And under those conditions, mineral systems become active, very active. Gold doesn't form randomly. It forms where conditions are right, and diorite often sits right in the middle of those conditions. Now here's what makes it powerful. Diorite is commonly associated with hydrothermal systems. That means hot fluids moving through rock. The same process we talked about earlier, but more aggressive, more concentrated. And when those fluids interact with surrounding materials, they don't just leave traces, they leave deposits, real deposits. But again, from the outside, diorite doesn't show it. It hides everything beneath a rough, dark surface. So unless you know what you're looking for, you walk right past it. Now imagine a hillside covered in diorite fragments. Nothing looks valuable. Nothing stands out, but inside some of those pieces, gold is sitting there, waiting, not because it's rare, but because nobody recognized it. And that brings us to something even more overlooked. Laterite. This one doesn't even look like a rock most of the time. It looks like dirt, rust-colored, loose, unimpressive. But laterite forms in tropical and subtropical environments, where intense weathering breaks everything down. And here's where things get interesting. As rocks break down, most materials get washed away. But gold stays, because it's heavy, because it resists chemical breakdown. So over time, as everything else disappears, gold becomes more concentrated, right there in the soil, in the laterite. Now imagine standing in a dry, reddish landscape, looking at what seems like nothing but low-value ground. But beneath your feet, gold has been quietly accumulating for thousands of years. Not in veins, not in chunks, but in distributed concentrations. Enough to matter, enough to change everything, if you know what you're looking at. And finally, we get to one of the most powerful gold indicators of all. Skarn. This is where things shift from subtle to serious. Skarn forms when hot fluids from magma interact with surrounding rocks, usually limestone or dolomite. And when that happens, a chemical transformation begins. The original rock changes, new minerals form, and more importantly, metals concentrate. Not just gold, but copper, iron, and other high-value elements. But gold can be a major player here. In some cases, skarn deposits have produced enormous amounts of gold, but visually, they don't always look impressive. They can appear chaotic, mixed, even ugly. Different colors, different textures, no clear pattern, and that lack of pattern is exactly what hides the value. Because people expect gold to be obvious. They expect clear signs, shiny indicators. But real geology doesn't work that way. It hides value in complexity. Now step back for a moment. Think about everything you've seen. Rivers carrying gold, hills releasing it, ugly rocks hiding it. This isn't random. It's a system, a process, a chain reaction happening across landscapes all over the United States. And most people only see the final stage. The gold in the pan, the gold in the river, but not the origin, not the source, not the rocks quietly breaking down over time, releasing that gold into the environment. So let me ask you something again. Next time you're walking through a rocky area, would you recognize syenite? Would you notice dolomite? Would diorite mean anything to you? Would you stop on laterite ground? Would you question a skarn formation? Or would you walk past all of it, looking only for what's already been revealed? Because that's the difference. between finding gold and understanding where it comes from. And once you understand that, everything changes. You stop chasing gold and you start predicting it. And that's where things get really interesting. Because in the next video, we're going deeper. Not into rivers, not into hills, but into something most people completely ignore. The exact patterns in American landscapes that silently point to hidden gold zones. Patterns that are visible, but rarely understood. And once you see them, you won't just find gold. You'll know where it's going to be before anyone else does. So the question is, are you just looking for gold, or are you ready to understand how to actually find it?